Well, hello again. Now, in continuation of the previous video, we will see these communication protocols strictly in ADAS context, in the context of some of the ADAS functionalities. Okay, here I go. In modern automobiles, advanced driver assistance systems rely heavily on various communication protocols to enable real-time data exchange between sensors, electronic controls, actuators, and displays. This is something which I touched upon in the previous video also. So, as per the roles and responsibilities of these protocols ensure fast, reliable, and deterministic communication, which is critical for safety and performance. Okay, now these are very important words. The protocols must be fast, reliable, and it must have a deterministic communication, and which is critical for safety and performance. I want all of you to see this picture very clearly so that you can get a clear cut idea about the various types of protocols that are being used in an automobile. In an automobile, these are all the kinds of protocols, or these are all the various languages that are used. Now just imagine this car is in India. Car is in India. In Tamil Nadu you speak Tamil, in Maharashtra you speak Marathi, in Karnataka you speak Kannada, in Telugu you speak, sorry, in Andhra Pradesh or Telangana you speak Telugu. Likewise, within the various parts of the vehicle, different languages are spoken, or different protocols are used. Okay. Now, when it comes to control area network, this is the most popular communication protocol. Okay, let me tell you, CAN is a huge subject in itself. It's an ocean in itself. So naturally, discussing the nitty-gritty of this CAN is going to be well beyond the scope of this tutorial. So I request all of you, in case you want to gain expertise in CAN, there are plenty of training courses. Plenty of training courses available on CAN. Especially, let me write one particular name. Sham Bhatt. His name is SHYAM Bhatt. BHAT. This person has developed a beautiful course on CAN, and that course is available in Udemy. In case you want to gain expertise in CAN, okay, this particular training course by Mr. Sham Bhatt elucidates the every nook and corner of this CAN protocol. I have seen many videos about CAN, but by far this course by Mr. Sham Bhatt is the best course for CAN. Okay, so in case you want to gain expertise on CAN protocol, well, go to Udemy, type Sham Bhatt, you will see the course. It should not cost more than 499 rupees, which is a decent investment, and you will have lifetime membership. So this course is certainly worth it. All right. Now coming back to CAN. CAN is the most widely used protocol for intra-vehicle communication, or it is the most widely used language for intra-vehicle communication, connecting ECUs for basic ADAS functions like parking sensors, collision warnings, and adaptive cruise control. Now, if you understand this trend, parking sensors and collision warnings, these are not exactly very high speed requirements. Especially parking means your vehicle is going very slow. Of course, collision is slightly faster, but it does not require as much bandwidth as transferring camera data to the ECU. In camera, you are actually transferring a video, live streaming a video from the surrounding to the ECU. So there you require high bandwidth. But for collision warning, it's not exactly a high bandwidth. Alright, so for this purpose, CAN is a widely used protocol. And what is the characteristics? CAN FD, this is a slightly new version of CAN flexible data. It supports up to 15 Mbps faster than traditional CAN. Traditional CAN, which was developed way back in 1980, it can support up to 1 Mbps, 1 megabyte per second. But the modern CAN version, it can support up to 5 megabytes. This is definitely an improved version of the CAN. And when it comes to topology, it is a multi-master broadcast based communication. Okay, so when I say topology, you must understand, for example, see this picture on the right side. Okay, see this picture on the right side. This shows that there are plenty of masters or plenty of entities within a car which originate this CAN message. Now, as I said, explaining everything in the CAN, like CAN arbitration or checksum or or all the CAN frame procedure, all these are well beyond this tutorial. That is very specialized within the CAN. In case you want to do PhD in CAN or anything like that, then it is very useful. But again, if you want to gain expertise on CAN, I go back to this particular gentleman, Shyam Bhatt, who has presented a wonderful course in Udemy. Now, limitations: limited bandwidth for high data rate ADAS applications. Which the limitation is, even though 1 Mbps is 1 Mbps or 5 Mbps is a huge amount, for ADAS applications it is falling short. It is falling short when it comes to ADAS applications. Now, this is the limitation. And again, ADAS use case, it is basically used for blind spot monitoring or tire pressure warnings and low latency control signals like emergency braking. Okay, now let's see the next language or the next protocol. LIN. LIN is local interconnect network. To be very honest with you, LIN is the most inexpensive communication protocol, and that is why it is used for low cost and low speed. Now, this is a very important criteria: low speed. For example, if you want to lift the window, you just press the button and window will close by itself. That does not require any high speed application. It is a very low speed application, and it has speed up to 20 kbps, which is far lesser than 5 mbps or 1 mbps of CAN FD or CAN. Okay, so this speed should suffice when it comes to lifting a window. Now, this is also having a topology of master slave architecture. Now, what is meant by master slave architecture, that is beyond the scope of this tutorial. You just understand that there will be one initiator and there will be one obeyer. There will be one slave which obeys, and there is one master which commands. Master sends a data or a signal, and a slave obeys. Now, what is the main advantage? The main advantage, it is cheap and simple wiring. I won't use the word cheap, rather I would use the word inexpensive. Okay, the main thing is it is inexpensive and simple wiring. And limitations is, of course, it is not suitable for high speed ADAS applications. Okay, and when it comes to ADAS use cases, rain sensors for automatic wipers, door control unit for safe exit assist. So I am sure everybody knows what is meant by safe exit assist. It is nothing but when door opens, it will warn you if some vehicle or pedestrian is coming right adjacent to your vehicle. Under those use cases, this is very important. Next comes FlexRay. Now, FlexRay has a speed of slightly higher speed of 10 Mbps. It is definitely faster than CAN. Now, what is this FlexRay? It is designed for high speed deterministic communication in safety critical systems. Okay, so next time when you see any ASIL D or ASIL C application, by default you will see a FlexRay protocol there. Understand this very carefully. Understand this very carefully, and let me reiterate: in safety critical systems, FlexRay is the protocol or language used. The biggest advantage is it is fault tolerant and deterministic latency. Now, what is meant by fault tolerant? So, even if some faults are there, this FlexRay has the capacity to withstand and work or serve its purpose. Alright, now this is the biggest advantage of FlexRay. Now, what is the limitation? Because of the higher speed, naturally it is expensive, and it is slightly complex when it comes to implementation. But this FlexRay is definitely very much in demand by many OEMs. Many OEMs are by default using FlexRay in the intra-vehicular communication. Understand this word very carefully: intra, not inter. Intra-vehicle communication, FlexRay is very rampant. And when it comes to ADAS use case, brake-by-wire system, which is used for adaptive cruise control, or active suspension control, which is used for automatic emergency braking, and high precision ADAS functions requiring time synchronization. So, wherever you require as close as possible to the real-time operation, FlexRay is mandatory, or FlexRay is mandated. Next comes the Ethernet. Ethernet, automotive Ethernet, or 100 base T1, 100 base T1, 1000 base T1. These are the various versions of automatic Ethernet. Next comes the specifications. What are the specifications of the Ethernet? First is, as you can guess, this has a very high speed, and that is the reason why this is used for video streaming, especially for camera application or LiDAR application, where maximum amount of data is transferred. This speed is used. Next comes the topology. Topology is point-to-point or switched networks, and the biggest advantage is high bandwidth, scalability, and supports high IP based communication. So 5G communication very much relies on Ethernet. And of course, the biggest advantage is high bandwidth, and that's exactly why in the ADAS use case I have mentioned camera and LiDAR data transmission. And of course, this over the air updates for ADAS software. And the biggest limitation is higher cost. Of course, it is higher cost, and it requires some specialized switches. It requires some very customized switches so that you can switch to automotive Ethernet whenever required. All right. I hope you are finding these various types of languages very interesting. And let me tell you, each and every protocol is a ocean in itself. And I request all of you, when you have time, please put your best efforts to learn as much as possible about each communication protocol. Please put as much effort as possible to learn as much as in depth about each communication protocol. I mean, to be honest with you, going in depth may not be required, especially if you are a ADAS engineer, because you have to select the right protocol depending upon the necessity. So just being aware about this speed, the payload, based on that you can decide which protocol is used. But how exactly do you send the data, that and all, if it all is required, that is usually taken care by the electronics engineers, who might be your colleagues in case you get a job in ADAS. They will be taking care of it. But in case you are curious, I strongly recommend you go in depth learning for each and every protocol. Next comes LVDS, or low voltage differential signaling. Now this is not exactly a very popular type of protocol, but still in some very customized cases it is used. Alright, what is the purpose? High speed point to point data transmission for video streams, especially for this video streaming. Actually, most of the video streaming happens through Ethernet, but in case you require some very high video stream for very high RPM cars like sports car or something, which can go up to 300 km per hour, then this LVDS can be used. It is a multi-gigabit speed. Okay, 3 to 6 GBS per SerDes links. I will explain to you what is meant by SerDes. Next is advantage. It has low electromagnetic interference and high noise immunity. Okay, so additional ambient noise will not make any difference to this particular type of communication. All right, and biggest limitation is it is very limited to short distance. Now I am sure everybody knows the entire wiring harness can go up to distance of 3 kilometers, 3 to 4 kilometers within automobile. All right, so but the biggest disadvantage is it is very limited to the very nearby components. Okay, and when it comes to ADAS use case, it is usually used in high resolution camera feeds, radar, LiDAR, sensor data. Okay, as you can see, for radar, LiDAR, sensor data, there are plenty of options. Ethernet is there, LVDS is there, even FlexRay is there. So there are plenty of options when it comes to radar, LiDAR data. Now next is the MOST, or media oriented systems transport. Now this is very popular when it comes to multimedia and infotainment. Okay, all the touch screens, all the human machine interface which you are sitting which is sitting right in front of the driver. For example, when you are in the driver's seat, you see a lot of multimedia on you. It may be a radio, or it may be a pen drive, or it may be a Bluetooth. All this multimedia and infotainment integration happens with the MOST, with the help of this particular protocol. And as you can see, this has a good high speed, because This is the one which actually dictates the user experience. For example, if you rotate a dial and volume should raise immediately, that will add to the good experience. But if you rotate a dial but volume will increase after 5 seconds, then it does not give the driver a good user experience. That is the reason up to 1 mbps is required, and that is the reason, because it is able to go up to 150 mbps, this is used for human machine interface or the infotainment. Next comes the advantages. It supports the audio video streaming. And when it comes to limitation, declining use due to Ethernet adoption. Now this is actually slightly, how to say, this is losing its popularity because Ethernet is gaining popularity. But well, who knows, tomorrow some research person can come up with some feature in most which will make it more popular. But as of now, it's slightly declining in popularity. Next comes the user use cases. First is augmented reality, and next is driver monitoring systems with video feeds. Now this driver monitoring system, which is inside the car, which is the ADAS functionality which works inside the car, it very much relies on this MOST, MOST. Let's proceed further. Next is this automotive SerDes. Well, to be very honest with you, this SerDes is still in the process of research. It is not exactly used in many productionized vehicles. Many productionized vehicles are using automotive Ethernet only, but this is rapidly gaining popularity because of the speed. 4 to 16 Gbps speed it is able to support. Okay, as it is mentioned here, the purpose is high speed data. Now this word is important. This high speed is the most important word. This can support the high speed data. Actually, many applications don't require this much speed. This is too high speed data supporting. That is the reason it is not yet very popular. I am sure it's a matter of time before this SerDes, or which is a acronym for the serializer and deserializer automotive SerDes, is definitely going to become popular in the near cases. Now ADAS use cases: multi-camera systems for 360-degree view and high resolution displays for ADAS visualization. Alright, next comes the wireless protocols, Wi-Fi and Bluetooth. These are not exactly very high speed applications, because when it comes to Wi-Fi, well, you can always connect the Wi-Fi in the car. I don't know about European countries, but in India, Wi-Fi is not yet a standard part of every car. Apart from some cars like MG Hector, other than that, many cars are not have not made Wi-Fi a mandatory part of the car. Okay, next is Bluetooth, in case you want to listen to some songs using your using some app on your mobile. For example, there are some apps like Ghana.com or Spotify where you can directly connect your mobile to the vehicle stereo. Okay, with so during that time Bluetooth is used. Next comes the V2X, vehicle to everything communication, which is going up to 5.9 gigahertz band. Now this 5.9 gigahertz band is supported by 5G mobile communication. Next comes the ADAS use cases, V2X for collision avoidance and Wi-Fi for high speed transfer. For example, HD map updates. Some vehicles, they are using inbuilt HD maps updates in the mobile, or in the display screen on the infotainment cluster itself. There is a separate unit which displays the HD maps. All right, so this is these are all the various types of protocols, and let's see in brief how they are faring with each other. Okay, when it comes to speed, CAN-FD 5 Mbps, it is for basic alert, basic ADAS alert. Strength is cost, and more, one important advantage of CAN is it is a very mature technology, because this came into picture almost 1980. There are many people who are how to say, experts in CAN-FD. So this is a very mature and robust technology, but the weakness is limited bandwidth. Next, when it comes to FlexRay, up to 10 Mbps, it can be used up to 10 Mbps. And it is deterministic fault tolerant, and is when it comes to Ethernet, 100 Mbps, high bandwidth sensors, and biggest strength is scalable and high speed. Next is this LVDS and SerDes. It is very high speed, multi Gbps it can handle, and it is basically used for camera radar data links, ultra low latency, point to point only. And V2X, of course, you know, it is vehicle to infrastructure communication. V2X means always vehicle to infrastructure communication, especially in the ADAS context. Now, what are the various trends? Now, Ethernet has upped the ante, or it has how to say raised the bar by releasing into market a new 10G plus Ethernet. Okay, so many OEMs are speculating that this multi-gig Ethernet is going to fast replace other protocols like SerDes or LVDS. Next important protocol is time sensitive networking and deterministic Ethernet for real-time ADAS. And of course, this 5G V2X, which I have already touched upon. And when it comes to conclusion, I would like to say that ADAS relies on mix of protocols like low speed, high speed, wireless. The choice depends on the bandwidth, latency, safety, and cost requirements. This is the major criteria. Now, let me end by some final thoughts. Okay, ADAS requires fast, reliable, and sometimes deterministic communication. And with trends moving towards centralized computing and autonomous driving, automotive Ethernet and SerDes are becoming dominant and popular, while protocols like CAN-FD and still support the lower speed data sharing. Now, only future will tell which protocols will become more and more popular. But as of now, OEMs, especially because Ethernet is released its new version called multi-gig Ethernet, many OEMs are yielding or showing lot of interest in Ethernet. Okay, thank you.